Shivaya. Good morning, good afternoon, everyone.
Good afternoon.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon. Hope you're all staying safe and fine, right? Okay, today is my first class for your batch. Yes, in this subject we are discussing about machine learning and data mining, right? Yes. Can you give a real example? Can you give a real example where machine learning and data mining techniques are being used today? Have you come across with any such scenario where these two concepts are being used? Hello, am I audible?
Ma'am, in investing money in different companies, like companies have their own data warehouse where they store all the data about how they invest, what returns do they get, and things like that. They basically mine that and use it for prediction, like investing in this company would give a better profit or something like that.
Yes, correct. Excellent answer. Any other answers? Okay. Yes, correct. One more example is um, I think you all have been using Amazon shopping website for shopping items, right? So I think you all are familiar with Amazon shopping. And while doing shopping on Amazon online, there you get a pop-up window down right side. That window says the products you may be interested in. So how are you getting that pop-up window while carrying out shopping, while browsing some items on the Amazon website? So how are you getting it? So assume that you have opened your shopping website and you have already logged in, you have an account, you have an Amazon account for shopping, and you logged in into Amazon shopping website, and then you keep on checking the items, newly launched products, dresses, whatever. So now here right down, okay, here down of the window, right side, you will get a pop-up window saying that the products you may be interested in. What is that pop-up window? How does it work? What is the technology behind that working tool? Any answers? Don't you think machine learning models are being run on our systems, laptops, when the systems are connected to internet? Of course, the systems, all our remote systems. I'm talking about the systems which are connected to internet. The systems which are connected to internet are able to run machine learning models. It is not our laptop running the machine learning model. The browser or a cloud server is running machine learning model across all the nodes, across all the laptops and mobile phones. So what exactly is machine learning? Machine learning is a technique, right? You know it, isn't it? What is machine learning? It is a data analysis method. Okay, it's a data analysis method. It is part of AI which learns from the history, uses some mathematical computations, and predicts accordingly based on the customer's interest. Okay, here customer's interest, I am referring the example of Amazon website. So what is the definition of machine learning? It is a method of data analysis that automates analytical model building. It's a branch of AI based on the idea that system can learn from data, identify pattern, and make decision with minimum human intervention. Yeah, same definition. This definition will take with respect to Amazon website. You have logged in into Amazon website and you are just browsing the items. You are just going to the newly launched products. So you get a pop-up window saying that these are the the products you may be interested in. So what is that pop-up window? Here a browser is running a model. Okay, there is a machine learning model. Machine learning model in the sense it is a it is a tool or it is a software which is making use of some equations. Okay, so that software is showing it's popping up a window, and how that window is working based on the recommendations from the system. So it is a recommendation window. That recommendation window is nothing but a machine learning model output. So what this recommendation, how this machine learning model is working, how this recommendation window is working in the Amazon website. I have purchased, let us assume that I have purchased some 50 dresses, okay, 50 dresses, and this data is stored and this data is existing since 1 year. So here the machine learning model, it is able to fetch my data, it is able to fetch my history, that is it is going to check my search patterns, it is going to see my history, it is going to check my search patterns, and then find some permutation combination, then predicts. Okay, based on my taste, based on my history, based on my search patterns, it is going to predict that if for example if I prefer to buy white dresses more, in that case it takes, yes, it generates the prediction for the products you may be interested in. So it will display the products which are white in color. So what this browser is trying to do, the machine learning model is trying to predict, and it is trying to attract the customer so that it can generate revenue for the company. Okay, so each and every machine learning model across different companies or businesses are mainly run to generate revenue. Okay, so what are the examples of machine learning? Machine learning is used in internet search engines. That is one example I gave, Amazon website. It is used in email filters to sort out spam or not spam. And it is used in websites or other official websites to make personalized recommendation. It is used in financial institutions to detect unusual transactions. And your lot of apps on your phone, such as voice recognition, also are run by the machine learning applications. So with this, we will move on. Yes.
Can you make everyone attendees?
It's not here. Are you not able to attend? Can you hear me? Am I audible or not?
Yes, ma'am, you're audible.
Is this a strength? Always? See here, I'm still new to Microsoft Teams. Okay, in my I was working with Wells Fargo. There we use Skype. So I'm still new to this Microsoft Teams. So I don't know how to make attendees here. Can anybody take the control? Here it is showing participants in the sense. You see, it doesn't matter whether you are attendee or not. You are there in the group, right? Does it matter?
If everyone are presenters, we can even remove people. So some are removing other people here. So that is the reason we ask to make everyone attendees except you.
Yeah, how to make it? Please let me know. Is there any other option? CR, where is CR?
Ma'am.
Yes.
Ma'am, just go to, beside raising hand, there's a three dots, no, ma'am.
Okay. Yes, 3 dots. Yes.
In that, is there anything like meeting settings, ma'am?
Meeting settings, device settings is there. Meeting settings is not there.
Okay, then ma'am, just open the participants list, ma'am.
Open the
participant list.
okay, participant list. Okay.
Yeah, I think you will be able to see some settings there, ma'am.
Manage permissions.
Yeah, yes, ma'am.
Okay. Just a minute. It's not opening. Yeah, just a minute. Network is too slow. System Microsoft Teams is very slow here.
Yes, ma'am. Sometimes it's closed down.
Are you able to see the screen? Hello?
Yes, ma'am.
Manage
Yes, ma'am.
I have to go here, right?
Yes, ma'am. Manage permissions.
Okay, it is running still. This is a problem with Microsoft software tools. Many companies do not prefer Microsoft. They go for Google. Are you able to see the screen now?
Yes, ma'am.
All three are running.
Oh, it's asking for sign in.
Sorry for the inconvenience caused. Yes, what I have to do here?
Only that one, ma'am. Who can present only me? That's all. Nothing else. Not this one, ma'am. You already did that.
I
Just
did.
save them.
That's all right.
Yeah. You're done, ma'am.
Okay, thank you. Okay, now with this, we will go to the subject, support vector machine. So what all models you have studied so far? Only KNN or other algorithms? I think only KNN, right? So next algorithm is support vector machine. Support vector machine is a machine learning algorithm which basically works on smaller data sets. It doesn't perform well on larger data sets. Okay, and it is a technique used for classification and regression. Okay, support vector machine is a technique or analysis technique which is basically used for classification and regression. What is regression here? What do you mean by regression? You have been studying regression so far. Regression is basically a mathematical approach uh, to find the relationship between two or more variables. Regression is basically used for predicting the behavior of one variable depending upon the value of other variable. And it is basically used to plot continuous values. The ultimate goal of regression is to plot a best fit line or a curve between the data. So can you give an example of regression? For example, house price prediction, right? When people are searching for a house for rent, that time the model can be generated. So what type of houses will go for rent most of the time? It depends on different parameters or different inputs or different attributes. What are the different inputs to the SVM model? Here the inputs to the model are house size, house location, how old is the house, locality. Okay, these are the inputs to the SVM model. So what is the SVM model output in case of regression? The chances of going for rent, the chances of renting a house is high. If the houses are located in remote areas, the chances of renting a house are very low. So here regression is basically used to predict continuous values. So SVM is used for regression. It is also used for classification. It means here you have mixed type of data, you have complex data, you have mixed type of data. SVM algorithm segregates the data into different classes. It means here let us assume that Amrita University students, there are Amrita has different branches across different cities, right? Amrita in Mysore, Amrita Bangalore, Cochin, Chennai, right? So yeah, let us assume that all students have been asked to attend a seminar. So now here main Amrita server is getting all this mixed data, and when SVM is applied to that mixed data, it is going to segregate. So students of Bangalore campus, students of Chennai campus, students of Mysore campus, students of Cochin campus. So it means the mixed data is fed into the SVM system, and SVM classifies the data into different classes. It is a supervised machine learning technique used for both classification and regression, but it is most commonly used for classification problems. And the ultimate goal of SVM is to divide data sets into into classes. It is used to segregate mixed data into classes to find a maximum marginal hyperplane. What is this maximum marginal? What is this hyperplane? Hyperplane is a line which divides the data set into different classes. Okay, we'll see that further. What is hyperplane? So this is the main goal. The main goal of SVM is to divide the data sets into classes to find a maximum marginal hyperplane. So now here, next, what exactly is support vector? It is based on the idea of finding a hyperplane. This is a plane. It is based on the idea of finding a hyperplane which divides the data into classes. Here we have a mixed data. Let us assume that we have a mixed data of green balls and blue balls, and there is a line here. This algorithm is creating a line, it is generating a line which divides the data into two different classes. And here you can see this green ball and blue ball, these are called support vectors. What are the support vectors? Support vectors are nothing but the data points which are closest to the hyperplane. Okay, these are called support vectors. And you know, this is x and y, it's a 2D plot. And data points that are closest to the hyperplane is called support vectors. And what happens if we remove this data plane? The data will be mixed, jumbled, and it is very difficult to bifurcate into classes. And here, the hyperplane plays an important role in data segregation. Okay, what is hyperplane? What exactly is a hyperplane? Hyperplane is a line that segregates the data sets into different classes. It divides the space, it divides the data space into two disconnected parts. Intuitively, the further from the hyperplane our data points lie, the more confident we are that they have been correctly classified. It means the line between these 2 points, the line between these 2 points should be large enough. Okay, this line should be large enough. The margin between these two lines should be large enough to separate the data sets. That is the intuition behind SVM. And the data point should be as far as away from the hyperplane. Then only the system will be able to correctly predict the data sets, the output. Next, how to find the best line or how to find the best hyperplane. Here we have to compute the distance between the hyperplane and the support vectors. What are support vectors? The points which are close to the line. Compute the distance between the line and the support vectors. This distance is called margin. The main goal is to maximize this margin. The hyperplane for which the margin is maximum is called optimal hyperplane. That is, the main goal of SVM is to find out the optimal hyperplane. Okay, so now look at this figure. We have two different data sets, the red squares and blue balls, and these data sets are separated by this line. Okay, by this line. So what are these? This is a support vector belonging to class A. Let us assume that this is class A and class B. This is a support vector of class A, and this is a support vector of class B. Now, what are the support vectors? Support vectors are the data points that are close, that are very close to the line. The next is to find the distance between the support vector and the line. We compute the distance between the support vector and the line. And distance between the first support vector to the plane and distance between second support vector to the plane form the margin. This is called margin. So here this total margin, this margin should be as large as enough possible. Here the margin, maximized margin, here we should make sure that this margin should be maximized between the two data points or between the two support vectors. So this maximized margin is called an optimal hyperplane. Next, how do we find the right hyperplane which segregates the classes? So here Data here, data are divided into two classes. It means data is linearly separable. By looking at this figure, what you can justify, the data is linearly separable. This is the first margin and this is margin, and this line is called hyperplane. And here data is linearly separable, data are segregated into different classes. But what happens when the data points are completely jumbled? Here all the balls are jumbled. How it is, the algorithm will draw a plane or a hyperplane? It is difficult, right? Here you can see this is a data which is linearly separable. Here also data which is also linearly separable, and here the hyperplane can be visualized as a 2D. Okay, this is a plane which is nothing but a line plotted in two-dimensional graph. And is it possible in this case, data is completely jumbled, data points of different classes are completely jumbled. Is it possible to draw a line in the 2D plot? No, data is completely jumbled. We cannot draw a line, or we cannot draw a hyperplane in using the 2D graph. Then what do? We shift from 2D to 3D. That is called kernelling. So here you have jumbled data. We move from 2D to 3D. That is, we are shifting from two-dimensional plot to 3D plot. So here the idea is that data continues to be mapped onto the higher and higher dimension until a hyperplane can be formed, and it is able to segregate the classes into it is able to segregate the data set into different classes. So can anybody say what is happening here? What is the difference between this and the previous graph, 2D graph and 3D graph? Here we have data in 3 dimensions. The hyperplane can no longer be a line, isn't it? It is no longer a line. It must be a plane shown in this 3D, right? So the idea is that data will be shifting, data will be divided into different regions, X, Y and Z regions, X region, Y and Z. So here basically what exactly we are doing, we are trying to visualize the data by adding one more line to the graph. Okay. So here this is one more example of complex data where the data is not linearly separable. So how do we do that? We add one more coordinate, that is called Z. Z is equal to x square plus y square. So basically what is Z? It is a dimension. It denotes an additional dimension, which is the square of the points from the origin. Square of distance of the point from the origin. X square plus y square is equal to Z. Here the data is converted from non-linear to linearly separable data using this equation. Z is equal to x square plus y square. So now we are adding one more coordinate to the graph. This purple line indicates the Z axis. So now what happens? X, Y line and Z line. This is one more additional dimension to the graph, and this is able to bifurcate the data into two different classes. So this works, this technology works for higher dimensional data. Now you can say that here the line, this line, it is separating the data in higher dimension, and we are taking a constant k, Z is equal to k, and we have already taken the equation x square plus y square is equal to Z. So substitute the value of k into Z. This gives an equation of a circle. So now we can project this linear separator, that is Z, into higher dimension back into the transformation. So when we introduce this Z, how this data is bifurcated. See here how this data can be visualized. So when the Z line is added, when the third dimension is added to the graph, here this is visible. So here data is visible. This is one class and the outer one is second class. So here, yeah, top layer, Z dimension is separating the data class 1 and class 2. So now we can say that by adding one more dimension to the graph, the data is linearly separable. Next, pros and cons of support vector machines. Pros is accuracy. As I said, it works well for smaller data sets. If the data set is smaller, definitely accuracy will be good. It will predict well, and it can be more efficient because it uses a subset of training points. In the sense, a subset of training points in the sense it is used for classification, right? So we use subset of training samples while training the model. Cons is it doesn't work well for data sets, larger data sets. Okay, because since they take data, very small data sets, the data have to be divided into chunks. So the processing time will be very slow. Training time will be very slow. And they are less effective on noisier data with overlapping class. Noisier data. What do you mean by noisier data? The data which may be having missing values, some junk values in the data set. Okay. Yes, SVM use cases. SVM is used for text classification such as category assignment, detecting spam, and sentiment analysis. It is commonly used for image processing techniques, image recognition challenges, performing particularly well on aspect-based recognition and color-based classification. Yes, SVM is also used for object detection. While traffic monitoring, object detection, it is used to this algorithm is used to detect different vehicles based on the image. So there is a server located at each traffic station. The server captures the images and sends it to the SVM model. Model is able to detect the vehicles and accordingly it is going to predict the traffic. But as I said, it works really well for the smaller data sets. SVM plays a vital role in many areas such as handwritten digit recognition, such as postal automation services. Next is, mathematics behind SVM. Here, mathematics is very important in order to learn SVM. You're going to study basic linear algebra, hyperplane, how it is mathematically modeled, how hyperplane is mathematically created, and how do you generate the equations if the data points are not linearly separable. Hyperplane, how it is denoted in the coding part, and how do you choose optimal hyperplane, mathematical interpretation of optimal hyperplane, and basic optimization term, and the last one is SVM optimization. So here in this topic, basically you are going to study the equations, mathematical equations behind the concepts. So vectors you already know, right? I need not explain it. Just to brush up, vectors, they are mathematical quantities which are both magnitude and direction. It is just a basic thing. Okay, and a point in the 2D plane can be represented as a vector between the origin and the point. And here OA, what is this? It's a vector, and length between O and A is its magnitude. Length of vectors. Length of vectors is also called as norms. What does it say? It tells us how how far vectors are from the origin. Okay, how the length of vector is calculated? Modulus of x. Modulus of x is equal to square root of the different independent inputs, x1 square plus x2 square plus x3 square, etc. Direction of vectors. Direction of vectors is calculated as x1 divided by modulus of x, x2 divided by modulus of x, x3 divided by modulus of x. So what exactly are the x1, x2, x3? These are the independent variables for the model. Next, dot product, how it is calculated in SVM. Dot product between the two vectors is a scalar quantity. Here, this basically, look at this equation, it shows how the vectors are interrelated. So what is the product? Modulus of u into modulus of v into cos theta. So what is this cos theta? It is the angle between the product, the vectors u and v. So if you take this, if you take the values, if you fetch the values for u and v, you will get x1 into x2 plus y1 into y2 cos theta. Next, hyperplane, how it is mathematically represented. It is a plane that clearly bifurcates the complex data into different classes. In case of 2D, two-dimensional, it is hyperplane is a line, and in case of 3D, hyperplane is a plane. It is called a plane. It is also called, hyperplane is also called n-dimensional line. Now you can see that here data points are linearly separable, right? They are clearly segregated into different classes. So this hyperplane linearly separates the data into two components. But here there is no clear separation. Okay, there is no clear separation. So what is the option? We shift from 2-dimensional to 3-dimensional. How do we do that? We add one more coordinate, z. Z is equal to x square plus y square. We compute a line and we add that line, and we will be able to visualize these data points. So that you saw how the data are visualized, upper layer and down. So basically this kernelling is basically used for data visualization, for analyzing. So here in the figure we saw a hyperplane is a line, and this hyperplane is a line. It divides the data into two classes. How that line is represented? Y is equal to ax plus b, right? What is this? It is the equation of a line. It is represented as ax plus b. And what is a here? What is a?
Slope of the line.
Yes, slope of the line. X is?
X coordinate.
X coordinate or the input, right? Independent variable. B is intercept of y, isn't it? You know this. So this equation y is equal to ax plus b holds true when x is not equal to 0, isn't it? And when you bring this y here, ax plus b minus y is equal to 0. And let us take the vector x is equal to x of y, x and y, and w is equal to a and minus 1. Then the vector form of the plane, it can be w into x plus b. The hyperplane can be represented as w into x plus b. What is this w? You already know this. You have already studied in KNN. What is this W?
Weight.
The weights.
Yes. Yes, weights. What does the weight indicate actually? In general, what is weight?
Ma'am, basically what extent of that particular input variable has to be considered, something like that.
Okay. Any other answers? What exactly is weight for the inputs? Why do we go for this parameter? You always come across with this parameter, weight, while dealing with independent variables and dependent variables. What is the importance? Can we ignore this parameter? What are weights? Have you studied biases, variances? Are you familiar with bias and variance? Okay, no answers. Okay, let us go back to the support vectors. What are support vectors? Support vectors are nothing but the data points that are closer, that are very closer to the hyperplane. So while segregating the data set into different class, the algorithm assigns weights to different data points. The points which are near to the plane are assigned some value, right? So they should be identified as the closest data points. That is, here I'll go back to the previous slide. Yes, in this, these are the vectors, right? Support vectors, support vector 1 and 2. Here there are other data points as well. So, but this should be identified as a support vector. The name is support vector, means the data point which is closer to the plane. So, in order to identify this as a support vector, in order to identify that this point is very near to the plane, algorithm is going to assign some weightage. It is going to assign some value in order to make it distinguishable. So here it is going to assign some weight to this and this data set also. For other data points, weights are assigned, but they are very minimum. But these two data points have high weightages. So this is one concept of weights. To identify the data points which are very close to the hyperplane. Okay, now this is the equation. Hyperplane is w into x plus b is equal to 0. So you already saw the data, mixed data or the unfiltered data is called raw data. That is always non-linear. It is not linear data. So to make it linear data, to segregate this mixed data into different classes, we add one more dimension. We add one extra dimension to the data points to make it linearly separable. So the process of making non-linearly separable data points into linearly separable data points is called kernel trick or kernelling. Basically, it is used for data visualization. Okay. And in companies and all, we don't use SVM because the companies, they have very large data sets. So we usually don't go for SVM. We go for XGBoost, random forest decision trees, and other latest algorithms, and using deep learning models. Yes, here also you can draw as many hyperplanes as possible. You can draw n number of hyperplanes between the data points. It means the data is linearly separable. And how to choose an optimal hyperplane. An optimal hyperplane is the line which divides the data points into uh, proper categories. So now here you can see class is class 1 and this is class 2, and these the points near to the line are called support vectors. These are support vectors and they are stored in the class support vector class, and this is class 1 and this is support vector class 2. But here in coding they take class -1 and class 1, that depends on the logic, one class and class 2. And here this is a hyperplane and the distance between these two lines, outer lines, is called margin. Okay, so here we have to make sure that this margin should be maximized, it should be wider, should be much wider in order to make correct predictions. The SVM goal is to choose an optimal hyperplane which maximizes the margin. Students, if you have any doubts so far in machine learning algorithm, you can discuss. I can share my knowledge of machine learning modeling, deep learning modeling with you if you have any queries regarding the projects. Anything you can ask now. We have 4 more minutes to go. Have you started coding in project? Have you started working on machine learning?
Yes, ma'am.
Okay. What platform are you using, all of you?
Collab.
Collab.
Yes, Colab. You need not use Jupyter. You need not install Jupyter, Anaconda, other things. Colab will take care of it. Okay. Have you all studied statistics in 3rd semester, 4th semester? Was there a subject statistics in 3rd, 4th semester, mathematics? Because ML comes from statistics. Probability, statistics, queuing theory, calculus.
Yeah, yes, ma'am. We have problems.
Yes,
Yes,
ma'am.
Then it will be easy for you
Sta-
to understand. Yes, it will be easy for you to understand the things. See, machine learning is not a rocket science. If you are good in coding and if you know the statistics to some extent, you can easily pick up in machine learning. And this generation student, these people, you people are very lucky because there are a lot of functions in Python, built-in functions. You just call those built-in functions, create variable, invoke those variables in the functions, just pass those variables in the functions. This job will be taken care by the Python built-in functions. You need not code from the beginning, from the scratch. So you people are lucky and you don't have to put a lot of efforts while doing coding. Only thing is you should know what kind of function should be used for different machine learning models. That comes only by experience. Okay, that comes only by experience. So use the same data sets throughout this semester, and as and when you learn each machine learning algorithm, you can include that algorithm for the same data sets, and finally you can compare the performance of all the algorithms and you can justify which algorithm shows better prediction. Okay, that was our intention. We asked you to stick on to the same data sets. for various machine learning algorithms. When are you supposed to submit the project as per the calendar of events? What is the last working date?
November 20 around, ma'am.
November 20th. Okay, still far. Have you all studied data mining in the database part in the previous semester? Do you people have any knowledge on data mining? Yes or no?
Ma'am, we just know what it is, ma'am, that's all.
Okay. Okay, fine. Okay, see you tomorrow, not tomorrow, on Monday. I'll be taking classes till 13th. I'm supposed to cover different concepts like linear discriminant analysis, principal component analysis. If the time permits, I will also teach feature engineering, which is very important for machine learning modeling. Feature engineering, yes, I would like to take classes on feature engineering. Let me see. If not now, towards the end, I can take class. Okay, see you all. Take care. Bye.
Thank you.
Thank you, ma'am.